Congratulations! You made it to Chapter 6. 6.1 is about simplifying algebraic fractions. So there's a few things we need to know before we can start jumping into the problems. Okay, first of all, there's our TBAT, Simplify Algebraic Fractions. It's in the section. If you don't write it down, you can check there for it. Here's what we need to know. A fraction is simplified if the numerator and the denominator, have no common factor. To simplify an algebraic fraction, you need to factor the numerator and factor the denominator before you do anything else. This is the biggest thing that students will get wrong in this section, is they don't factor first. Factor, 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 factor first. First, a little review. If I want to simplify this fraction, I'm going to divide the top and bottom by a common factor. That's kind of the same idea as we're doing today, except that we want to look at the factors a little bit differently. Today what we're going to end up doing is factor the numerator by creating a multiplication problem like this. 2 times 2 times 2 times 3 is 24. I'm basically writing their prime factorizations. 30 is 2 times 3 times 5. To simplify this fraction, we are going to cancel the factors that they have in common. Because 2 divided by 2 is 1, and 3 divided by 3 is 1, the important numbers of this problem are really the 2 times 2 on top and the 5 on the bottom. That means this fraction simplifies to be 4/5. We're going to do the same thing today. Instead of numbers canceling, however, we could have factors like x plus 2 or 3x plus 1 canceling. So for example, in this algebraic fraction, the top is completely factored, the bottom is completely factored, and I can I can cancel the common factors. The simplified version of this algebraic fraction is 3x plus 1 over x minus 2. So how do we simplify this? By factoring first. The numerator, both terms in the numerator have a 3 in common. Both terms in the denominator also have a 3 in common. These 3's are what can cancel. Notice, I am not going to cancel the a's. They are attached with addition to something else. The entire factor here is a plus 2. If I want to get rid of anything here, it has to cancel completely with another a plus 2. I cannot cancel with these two a's. So my simplified version of this fraction is this. All right. The one other piece of this lesson has to do with restrictions. And when we talk about restrictions in terms of fractions, it's because we have something in the denominator that could possibly be 0. A minus 2 could be 0 if a was positive 2. If a was positive 2 and I plug it into this fraction, I would get 0 in the bottom. I cannot have that. So in whatever I get once I simplify this, I must at the end say that a cannot be 2. So I would say your first step in any of these problems is to look for restrictions in the original problem. So part of my answer to this is that a cannot be 2. What is a simplified version of this fraction? Let's look into that. The numerator can be factored because both terms are divisible by 5. Once I do that, I see that I have the same factor on top as I do on the bottom. If it helps, you could put the a minus 2 in parentheses. This will cancel with this, and I'm just left with 5. So my final answer is 5. That's a simplified version of this fraction, but with the understanding that a cannot be 2. So when the directions in your homework say simplify, give any restrictions on the variable, here's your simplified version, here's your restriction. Simplify, give any restrictions on the variable. First thing I'm going to look for are my restrictions. Remember, any value that would make the denominator 0, you must claim as a restriction. So in this case, I'm looking at 5 minus x. Well, here, if x is 5, then I'm going to have 5 minus 5, and that is 0. So x cannot be 5. I also have this factor over here, though, that could have a variable for x. And just like when we solved using the zero product property, x cannot be negative 2/7. How did I get negative 2/7? Well, if you're not sure, I'm really saying, okay, what value for x would make this 0? I'm subtracting 2, and then I'm dividing by 7. And that's where I get my negative 2/7. So this algebraic fraction has two restrictions. X cannot be 5 or negative 2/7. Those two values, if we plug it in, will give the denominator, or make the denominator 0. You cannot divide by 0. Alright, now that I have the restrictions, let's simplify. Do I have any factors on the top that can cancel with the factors on the bottom? Lucky for us, this whole thing's already factored. I just need to see what can cancel. These two terms are not exactly the same, but they are equivalent because I'm adding, and I'm adding 2 with a 7x, and it doesn't matter what order I do that in, so I can go ahead and cancel these two. Sorry for the break in the video, Mrs. Willis walked in. So let's see, we canceled these. What's left over? Is this something that we can cancel? Well, they're not exactly the same, are they? You know, one is, we have x and 5, but there's subtraction. And these are actually opposites of each other. Just like when we did the factor by grouping in the last chapter, we want to realize that if I factor out a negative 1 from this bottom one, I switch the order of subtraction, and they become exactly the same. But I'm doing that by factoring out a negative 1. Now, they cancel. And if they cancel, I'm left with nothing on top. Remember, canceling, we're canceling because this divided by this is 1. So this is 1 and this is 1. So I have 1 divided by negative 1. My answer is just negative 1. Remember that your complete answer is going to have negative 1 with the restrictions that x cannot be 5 or negative 2/7. Alright, so here's a super hard one. First thing I'm going to do is look for restrictions. In order to look for restrictions, I'm looking for any value of variables that is going to make the denominator 0. Well, this seems pretty complex, and if I want to figure out when this equals 0, I need to do some factoring work. So I'm going to zoom in just on this piece right here, and we're going to factor it. Okay? It's already equal to 0. That's good for ZPP. I need to factor this one, and I'm going to use a box to do so. Sorry. 10x squared minus 18y squared. Looking for two numbers that multiply to be negative 180 x squared y squared and add to be 3xy. If I go through, grab a calculator and start dividing with 180, I'm going to come up with numbers that are 12xy and 15xy, and I believe that I want the 12 to be negative so that they add up to be positive 3. Alright, so negative 12xy, oh my goodness, I did not draw a big enough box. Let's try this again. So my final answer is this. Now we haven't done any problems yet dealing with solving equations and zero product property where we have multiple variables. We're still going to do the same steps, but the answers are going to look a little bit weird. So here's what we have to do. We have to split these up into two smaller equations. There's one of them. There's the other one. Okay? I'm going to solve one of these equations for one of the variables. It doesn't matter which one I pick. I'm usually going to pick the one farthest to the left or with the first alphabetically, but I would not mark it wrong if you ended up picking the other one and solving it out in any kind of test or quiz question. So I'm going to solve this equation right here for x. I'm going to add 6y to both sides and divide by 5. So x equals 6y over 5. This one I'm going to solve for x again. If you pick x over here, pick x over here, subtract 3y from both sides, divide by 2. Now remember, all of this process is we're trying to figure out restrictions, values for x and y that the denominator cannot be, so it won't end up being 0. So these are actually the values I do not want. And so these are my restrictions, that x cannot be 6y over 5, or x cannot be negative 3y over 2. Those are my restrictions. Set the denominator equal to 0 and solve. Alright, well, all that work just to find restrictions. Let's go back and try to simplify the fraction. So, over here, I already had factored the denominator in my whole quest for restrictions. So let's just write down what those things were. Alright. And the top, the numerator, well, that's a relief that because it's easy to factor. It's the zero product property. Nope, I lied. It's the difference of perfect squares. This is a y. 5x minus 6y. Now, do I have any factors that cancel? You betcha. I have this guy right here, the 5x minus 6y, and the 5x minus 6y are in the top and the bottom. So my final answer here, 5x plus 6y is left on the top, 2x plus 3y is on the bottom. Notice I'm not going to write them with parentheses unless there's something else being multiplied there. Since this canceled out, I'm only left with this. You can write the parentheses, you can, you don't have to. That'll be up to you. Alright, so our final answer here is that this is the simplified fraction, and then way over here are our two restrictions. This is a simplified answer as long as these restrictions are happening.